Hello everyone and welcome to another Math tutorial video. Now I'll be discussing Form 4 Additional Mathematics, Chapter 9 Solution of Triangles, HOTS question example 1. Okay, before that, please like this video to show your support and subscribe to the channel for more upcoming mathematics tutorial videos in the future. Okay, let me read the question now. The following diagram shows a quadrilateral ABCD such that angle ABC is an acute angle. So as you can see here, this is the angle ABC. So continue to read the question. For the question part A, they ask us to find angle ABC followed by angle ADC and the area in centimeter square of the quadrilateral ABCD. So this is for the question part A. Continue to read the question part B. Another triangle AB prime C has the measurements that are same with the triangle ABC, which is AC is equals to 15 centimeter, CB prime is equals to 9 centimeter, and angle B prime AC is equals to 30 degree, but different in shape from the triangle ABC. So the question asks to sketch the triangle AB prime C and state the angle AB prime C. So this is the overall question. So I hope that you will attempt this question in the future. If you could manage to solve this question, a big thumbs up to you guys. But if you can't solve this question, no worries. I'm going to show you the step-by-step working and the solution. So without further delay, let us start to solve the question. Let us start our discussion for the question part A. Okay, for the question part A, we need to find the angle ABC followed by angle ADC and then the area in centimeter square of the quadrilateral ABCD. Okay, within this quadrilateral ABCD, as you can see here, it is having two triangles. Okay, so we will have a look at it later on, but for now we will solve the angle ABC first. Okay, so from here, in order to solve the angle ABC, we are going to use the sine law. Okay, if you don't know how exactly the sine law works, okay, no worries, I'm going to show the formula now. Okay, you can use this formula as your guidance, guys, okay, in order to solve for the question A part 1. Okay, so from here, let us begin our working. So by using sine law, okay, so from here, sine 30 degree okay, divide with the adjacent length, which is 9 centimeter in this case. Okay, let me underline the fraction. And then equals to sine angle ABC okay, and then you divide with the adjacent length, in this case is 15 centimeter. Okay, let me underline the fraction. Okay, so from here, let us proceed to find the sine angle ABC. So in order to find the sine angle ABC, so what you're going to do is this 15 centimeter, we're going to times with sine 30 degree and then you're going to divide with 9 centimeter. Okay, let us proceed our working. So from here, sine angle ABC will be equals to 15 centimeter. Okay, and then you times with sine 30 degree. Okay, and then you divide with 9 centimeter. Okay, let me underline the fraction. Nine centimeter. Okay, so let me copy paste this. So from here, you calculate this, you should get your sine angle ABC is equals to 0.8333. Okay, so I'm calculating this and I'm stating my calculation in terms of 4 decimal places. Okay, So from here, to find the angle ABC, what you do, you sine inverse this value. So from here you should get angle ABC is equals to 56.44 degree. So this is your answer for question A part 1. Okay, let me underline the angle ABC. Let us proceed our discussion for the question A part 2, where we require to find the angle ADC. So if you are wondering why is the angle ADC, is over here. So this is the angle ADC. Okay, in the first triangle diagram here, at least the angle is given to you, which is 30 degree. But if you take a look over here, none of the angle is given, only the length of the triangles are given. So from here, how you are going to find the angle ADC? So we are going to use the cosine rule over here. Okay, so if you don't know how to use the cosine rule, okay, no worries, I'm going to show you the formula now, so you can use that as your guidance in order to solve the question A part 2. Okay, so let me begin the working now. Okay, by using the cosine rule, from here the length of AC is given, and then the length of AD is given and followed by length of DC. Okay, so from here we are required to find the angle ADC. So we're going to apply all the information into the cosine rule formula here. Okay, let us start. So from here, AC square is equals to AD square plus with DC square minus with 2 times with AD times with DC times with cos angle ADC. Okay, so let us substitute all the respective value. Okay, so from here 15 square will be equals to 10 square plus with 8 square minus with 2 times with 10 times with 8 times with cos angle ADC. Okay, so from here we are required to find the cos angle ADC. So from here, to find the cos angle ADC will be equals to 15 square, okay, minus with 10 square minus with 8 square. So this 10 square and 8 square in the right hand side, you move it to the left hand side. That's how you get the minus over here. Okay, so from here, okay, let me underline the fraction over here. And then negative 2 times with 10 times with 8, this one you have to divide. Okay, so from here, divide with negative 2 times with 10 times with 8. Okay, you perform the calculation. So from here, you should get your angle ADC is equals to 112.41 degree. Okay, so when you press in the calculator, okay, for this calculation you will get a value, and that value, what you do, you cos inverse. So that's how you get the angle ADC. Okay, where you get here 112.41. okay, so let me underline the angle ADC. Okay, so from here let us proceed our discussion for the question A part 3, where we require to find the area in centimeter square of the quadrilateral A, B, C and D. Okay, as you can see here, this is the quadrilateral. Okay, so from here what we're going to do is we're going to split this calculator into two sections. Okay, as you can see here, this is the triangle 1 and this is the triangle 2. Okay, we're going to find the area of triangle separately, and then towards the end we're going to sum them together. Okay, so from here that will be the overall idea on how we're going to solve the question A part 3. Okay, let us begin by solving the triangle 1. Okay, so from here let me write in the working triangle 1. Okay, so to find the area of triangle 1, the first step what we need to do is we are required to find the angle ACB. So let me write the working here. So the step 1, find angle ACB. Okay, there is a reason why we need to find this angle. Okay, let me scroll this up. Okay, so if you take a look at this triangle, only angle ABC, which you have already found in the question A part 1, and angle BAC is provided. Okay, if we are required to find the area of triangle, we need at least two length of a triangle and one angle which is coincide with these two length. Okay, length AC is given over here, but unfortunately length AB is not given, so we are unable to find using this sine 30 degree. Okay, and same thing over here, angle ABC is given as 56.44, but then we don't know the length of AB, so this angle also is not possible. So the only way which is possible is by using the length of AC and CB and finding the angle ACB. Okay, so how are we going to do that? So let me show you the working now. So from here the total internal angle of a triangle is 180 degree. So from here to find the angle ACB, will be equals to 180 degree, okay, minus with 30 degree, okay, and then minus with 56.44 degree. Okay, so from here you calculate, you should get your angle ACB is equals to 93.56 degree. So this is your step 1. Okay, let me underline the angle ACB. Okay, so once we're done with the step 1, let us proceed to the step 2, where we can proceed to find the area of triangle 1. Okay, let me write the working over here. Okay, so from here we are going to find the area of triangle 1. Okay, in order to find the area of triangle, you need to use this particular formula which I'm going to show you now, so you can use that as your reference. Okay, so from here let us calculate the area of triangle 1. Okay, from here the area will be equals to half, okay, times with the straight line AB, I mean the length AB, okay, and then you times with the length CB, okay, and then you times with the angle sine ACB. Okay, so this is the working, guys. Okay, so let us substitute all the respective values in our working here. Okay, and then equals to half times with 15, okay, since AB is 15, okay, and your CB is 9, okay, and then sine angle ACB is equals to sine 93 0.56 degree. Okay, so from here you calculate all, you should get your area of triangle 1 is equals to 67.37 centimeter square. So from here 67.37 centimeter square. So this is your area of triangle 1. Okay, so let me underline this. Okay, once we find the area of triangle 1, let us proceed our calculation to triangle 2 now. Okay, so let me underline this. So as I mentioned in my early discussion, if you take a look at the triangle 2, there is no angle given, only the length of the three sides of the triangles is given. So by using the three sides of the length of the triangle, it is possible for us to find the area of triangle by using the Heron's formula. Okay, so if you don't know what is a Heron's formula, so I'm going to show it to you now, so you can use that as your reference, and we're going to apply that in our calculation here. Okay, so in order to apply the Heron's formula, so the first step what we need to do is we need to find the S. Okay, but before finding the S, let us identify the coefficient A, B and C respectively. Okay, it is up to you to set which one is A, which one is B and which one is C. Okay, so from here I'm going to set my A, in this case is equals to 10 centimeter. Okay, and B is equals to 15 centimeter. Okay, and my C is equals to 8 centimeter. Okay, so once you identify the A, B and C, now we can apply the Heron's formula. So let me write in the working here. Using Heron's formula, okay, so from here the S is actually equals to A plus B plus C, and then you divide with 2. So from here it will be 10 plus with 15 plus with 8, okay, and you divide with 2. So let me divide with 2 now. Okay, so from here you should get your S is equals to 16.5 centimeter. Okay, so this is your step 1 by identifying the S. So let me underline this. Okay, so once we identify the S, now we can find the area of triangle. Okay, so from here, to find the area of triangle, will be equals to, okay, so from here let me write the formula over here. Okay, S, okay, and then you times with S minus A, okay, and then you times with S minus B, okay, and then you times with S minus C. Okay, you times everything and at the end you should square root this. So that will be your working in order to find area of triangle using the Heron's formula. Okay, so from here let me include all the variables in the formula here. So from here the S is 16.5 centimeter. Okay, in this case I just write 16.5. okay, close bracket. Let me write this properly. Okay, so from here S minus A in this case will be 16.5 minus with 10. Okay, so from here your S minus A will be 6.5. Okay, and then followed by S minus B. Okay, in this case will be 16.5 minus with 15 centimeter. Okay, in this case will be 1.5. Okay, and the last S minus C, okay, in this case is 16.5 centimeter, you minus with 8, so you get 8.5. Okay, you times everything and then you square root it. Okay, so when you times everything, you should get 1367.4375. Okay, so from here, when you square root this, you should get your area of triangle is equals to 36.98 centimeters square. Okay, so let me underline the second area of triangle. Okay, once we able to find the area of triangle 1 and area of triangle 2, okay, now we can able to find the total quadrilateral area. Okay, that will be our final step in solving the question A part 3. Okay, so from here, to calculate the total quadrilateral area, is equals to area of triangle 1, in this case is 67.37 centimeter square. Okay, and you plus with area of the second triangle, which is 36.98 centimeter square. Okay, you add these two area together, so from here you should get your answer for the question A part 3 is 104.35 centimeter square. Okay, so this is your final answer for the question A part 3. Okay, let me underline the solution. Let us proceed our discussion for the question part B now. Let us proceed our discussion for the question part B. Okay, based on this statement given in the question part B, so this question is actually involving the ambiguous case. Okay, so you can wonder, what is an ambiguous case? Okay, ambiguous case is actually a formation of two triangles in one single triangle. Okay, that means that in one particular triangle you can able to form two triangles. Okay, that is called an ambiguous case, guys. Okay, so that is the overall idea based on this statement. Okay, where they require you to find the second triangle. Okay, for the question B part 1, they ask you to sketch the triangle AB prime C. Okay, as you can see here, these are the conditions that you need to fulfill, where your straight line AC must be equals to 15 centimeter. Okay, just like this, straight line AC must be 15 centimeter. Okay, and CB prime, okay, the length of CB prime must also equals to 9 centimeter. Okay, and this is the second condition. Okay, and the third condition is angle of B prime AC must be equals to 30 degree. Okay, these are the three conditions that you need to fulfill in order to sketch the triangle AB prime C. Okay, so from here I've already sketched the triangle AB prime C for you. Okay, let me show you the complete sketch now. Okay, so this is the complete sketch of the second triangle. As you can see here, this is the triangle AB prime C. Okay, as you can see here, the length of AC still remains the same, which is 15 centimeter. Okay, and the angle of B prime AC still remains the same, which is 30 degree. Okay, and the length of B prime C is also the same, is 9 centimeter. Okay, this is the example of an ambiguous case. As you can see here, you are forming two triangles. Okay, as you can see, this is your triangle 1 and this is your triangle 2 within one big triangle over here. Okay, so this is for the question part 1. Okay, from here let us proceed our discussion for the question B part 2, where we require to find the angle of A B prime C, which in this case this angle over here. Okay, so to find this particular angle, we are still going to use the sine law. As you can see here, there is one angle is already given for us. So in this case, sine law is possible for us to use, okay, in order to solve the question. So from here, let us continue using sine law. Okay, from here, sine 30 degree, okay, you divide with the corresponding length, in this case is 9 centimeter, okay, and then equal to sine angle A B prime C, okay, which is this particular angle, sine angle A B prime C, okay, and then you divide with the corresponding length, which is 15 centimeter. Okay, let me underline the respective fraction for two sides. Okay, so from here, for the next step, what you're going to do is, in order to find sine angle A B prime C, 15 centimeter will be times with sine 30 degree and you divide with 9. Okay, so from here, sine angle A B prime C will be equals to 15 centimeter times with sine 30 over 9 centimeter. Or you know what, let me just be consistent in my calculation and we include our units towards the final answer. Okay, so from here let me underline the fraction. Okay, there is nothing wrong, guys, if you don't include your units during the calculation. It is important that you must mention it towards the final answer. Okay, so from here you should get your angle angle A B prime C. So how you get the angle A B prime C? Okay, this calculation you calculate it, okay, and that answer you sine inverse it. So from here, angle A B prime C, okay, but be careful, guys, there is a catch over here. So as you can see here, when you calculate it, you will get your angle A B prime C is in acute angle. But then if you take a look at this diagram over here, it is an obtuse angle. Okay, that means that if you include acute angle and you just leave your answer in that way, your answer is actually wrong, guys. Okay, since it is an obtuse angle, so what you need to include it. So from here, 180 degree you need to minus with 56.44 degree. Okay, obtuse angle means your angle is more than 90 degree but less than 180 degree. Okay, if you leave your answer just like 56.44 degree, okay, it indicating that you're finding for angle A B C, not angle A B prime C. Okay, there is a big difference over here. Okay, so from here you calculate this. So from here you get your angle A B prime C is equals to 123.56 degree. So this is your final answer. Okay, let me underline the solution. Okay, so that is all for the step-by-step working and solution for this question. I hope you understand the full working that I've shown to you. If you like this video, please give your thumbs up. If you haven't subscribed to the channel, please subscribe to the channel and hit the bell icon for more upcoming mathematics tutorial videos in the future, and not forget to share this video. Thank you everyone for your support, and I'll see you in the next video.